Good morning, children. Today we are going to discuss in this video mechanism of a complex process. It's not visible to you, anyways. That's what I'm telling. Mechanism of a complex process. Suppose this process, decomposition of ammonium nitrate to form nitrogen and water. On doing experiment to find the rate law, it is said that the rate law is for this reaction. After we perform experiment, it comes out to be like this. So it is a first order reaction, and since coefficient here and here it balances, we say that it is a elementary process. This elementary process, it takes place in one step. So order of this reaction is 1, and the molecularity of this process is also 1. Coming to the second reaction, decomposition of hydrogen iodide. On doing experiment, we get the rate law to be Hi squared. So once again you see it is matching with this the reactant coefficient. So it is also an elementary process. And the order of this reaction is 2, and simultaneously two molecules are colliding for the process to take place. So molecularity of this reaction is also 2. And in the same way, for this reaction, the rate law is found to be K NO square O2. Remember, this rate law we are not writing according to the coefficient. We are writing this after performing experiment. And we see that the coefficients, the powers here are matching with the coefficient. So it is also a elementary process, and it is a third order reaction, second order with respect to NO, and first order with respect to O2. So these are all processes which takes place in one step, and these are called elementary processes. But if you consider this reaction where we have how many particles in the reactants, 1 plus 6 plus 3, 10. Okay, now certainly it cannot be elementary process, because 10 particles cannot collide simultaneously. 10 particles cannot collide simultaneously. So it is an example of complex process, and since it is a complex process, it cannot take place in one step. It takes place in large number of steps, and writing steps for a complex process is what is known as mechanism of reaction that we had discussed the other day. So a complex process, a complex reaction cannot take place in one step, and writing steps for a complex process is called mechanism. Now we are going to explain it with the help of one illustrative example. Suppose decomposition of N2O5, decomposition of nitrogen pentoxide. And it is like this: N2O5 arrow NO2 plus O2. Decomposition of pentoxide takes place in this way. There it is 2, there it is 4. So this is a decomposition of pentoxide, and on doing experiment, the experimental rate law, we get the quantity K(N2O5). This is the rate law we get from performing experiment. So there you see the power of this concentration term is not matching with this coefficient. So since it is not matching, that means it is a complex process. It is a complex process, and complex process will have a mechanism. So we are writing a mechanism. We are suggesting a mechanism for this complex process. Okay, suppose step one, what we have is say N2O5 breaking down into NO2 plus NO3. Suppose this is step 1, N2O5 is breaking down into NO2 plus NO3. Now you see this process, this equation is balanced. This equation is balanced. And one more thing that you see, NO3 is nowhere in this reaction. So NO3, which is formed here in step 1, which is nowhere in the main reaction, it is called an intermediate. So this is an intermediate. This is an intermediate. Now, in the mechanism, the intermediate should disappear ultimately. The intermediate should disappear. So, keeping that thing in mind, we can write the second step like this: NO3 plus N2O5 will be NO2 plus O2. Okay, so if we write the second step like this, and second step also need to be balanced. To balance, we have total of 3 nitrogens. So if I write here 3 nitrogen, then I think it got balanced. Okay. So these are 2 steps we have written. Now there won't be any more step. Now whether it is correct or not, on adding the steps, main equation should come. You can see if you add this 2, okay, this thing is going to come. So this is the mechanism. Okay, this is a mechanism supporting this complex process, because on adding this thing we cancel with this one and we get this one. Okay, one more thing in mechanism, okay, is that this step is found to be taking place slowly. It is a slow process, whereas this one is a fast process. This is slow, this is fast, and the other day we were discussing that the slowest step is the rate determining step. The slowest step ultimately determines the rate of a complex process. Okay, so and you see the rate expression, as I say, will depend on the slow step. Okay, so you see the coefficient of the reactant of the slow step and the rate law expression is matching. It has to match. The coefficient of the first step and the rate law expression should match, and keeping that thing in mind, we should suggest the mechanism. So this is mechanism of a complex process. So now one more thing let me say you is that if you are asked what is the molecularity of this process, what is the molecularity of this complex process? Complex process doesn't have molecularity. Molecularity of a complex process is meaningless. Elementary process they have molecularity. For example, molecularity of this step is 1, molecularity of this step is 2. Okay, but molecularity of the complex process, it doesn't happen. So I will be giving you some more questions, later on to write mechanism. Okay. Now we are going to discuss another thing that that temperature has a profound effect on rate of a chemical reaction, and there is one equation called Arrhenius equation. So that we are going to discuss now. So yes, Arrhenius equation. It is saying that a rate of a chemical reaction is found to become double or even at times 3 times for just 10-degree rise in temperature. This thing we write in this way: rate constant at T plus 10 Kelvin divided by rate constant at T Kelvin is very nearly equal to 2 to 3. Because if rate constant gets double, the rate also will get double. And this term is called temperature. This term is called temperature coefficient. This is called temperature coefficient. So if you are asked what is temperature coefficient, you can write this expression. Okay, now Arrhenius equation is K is equal to A e to the power minus EA by RT. This is Arrhenius equation where K is the rate constant, A is a Arrhenius constant, also called pre-exponential factor. This term EA is called activation energy. We are going to discuss in detail about the activation energy in the next video. R is universal gas constant, T is the temperature in Kelvin scale. Now we can have this in the logarithmic form. This is the exponential form of the equation. The logarithmic form will be ln k is equal to this product. In case of logarithm, it becomes like this: ln a plus ln e to the power minus ea by rt. Further step, ln a power gets multiplied between minus ea by rt ln e. So it is ln a minus, now ln e, it is actually ln e to the base e. Ln means when the base is e, and ln e to the base e value will be 1. So it will be minus ea by rt. Now let us make it common logarithm. We have to multiply by a factor of 2.303. So log k is equal to 2.303 log a minus ea by r. Okay, and if we divide both sides by 2.303, we have log k is equal to log a minus EA by 2.303 R T. So you see, this is the Arrhenius equation in logarithmic form, and you can see that this equation is of the form of y equal to m x plus c. So y is matching with log k, the c is matching with this one, m is matching with this one, x is matching with 1 by t. Since we know log y equal to mx plus c gives us a straight line, so naturally you can say that if we make a graphical plot, if we plot this side log k, and this side the variable is 1 by t, if I plot here 1 by t, so log k versus 1 by t will give a straight line to us with positive slope or negative slope. You see here is minus, so it's negative slope. We get a straight line with negative slope, so you know this is positive slope, this is negative slope. So we get we'll get experimental points like this. So this will be the graph. So from the graph, you know, the intercept will give us the value of log a, whereas the slope will give us the value of minus EA by 2.303 R. That is from the slope we can get the activation energy of the reaction. So children, this much for now. We will be discussing how to experimentally determine activation energy, in the next video. Till then, bye bye.